ISO 19650 Part 3. In practice. Managing information once a building is in use. The most expensive phase is everyday operation. The project comes to an end, but the real costs are only just beginning. The operational phase spans years of maintenance decisions, inspections, failures, and upgrades. When information about managed assets is fragmented, the asset owner pays the price through delays and increased risk. ISO 19650 Part 3 brings structure to information management after handover, consolidating the most practical aspects of the BIM approach into a single framework. In this article, I outline the key provisions of the standard from a practical perspective. My intention is to show that any asset owner or operator can find real value here, regardless of the type of asset or the way their organization works. AIM, the Information Command Center. The purpose of the process, described in the standard, is to maintain and develop the Asset Information Model, AIM, a structured set of information that supports asset management decisions. The first iteration of the AIM is the ACE Built Information Model, reflecting the condition of the asset at the point of handover. At this point, as usual, I need to briefly complain about the ambiguity of the word model in the term information model. ISO 19650 Part 3 is clear. The AIM is an organized collection of information used to manage and maintain an asset, and it may include both geometric and non-geometric data. In practice, this means that an information model can take the form of a database, drawing sets, spreadsheets, or documentation, such as operations and maintenance manuals or technical documentation, without any requirement to create a 3D model. Following the fit-for-purpose principle, the asset information model should contain only the information necessary for the effective asset management. That said, I strongly encourage exploring the considerable advantages of documentation in 3D compared with traditional flat documentation. In simple terms, the asset information model can be described as an organized set of information about an operational asset. It is a digital description of the building that helps us understand what we manage, how our assets function, and what they require for day-to-day operation. 8 steps to preparing an asset information model. In brief, ISO 19650 Part 3 retains the 8-stage process familiar from Part 2 of the standard. Assessment and need. Invitation to tender. Response. Appointment. Mobilization. Information production. Information acceptance by the appointing party. Aggregation into the AIM. What primarily differentiates Part 3 from Part 2 is the concept of trigger events. In design and construction, progress is defined by milestones and schedules. In operation, the rhythm is set by trigger events, as defined in this part of the standard. These are classified as planned events, for example, inspections or end-of-life replacement. Unplanned events, such as failures or weather-related incidents, and asset acquisition scenarios. Each of these events may initiate the creation or update of information within the asset information model. 3 process paths: plan, react, acquire. The standard distinguishes 3 information flow scenarios depending on the type of trigger event. Planned events. In this scenario, tendering and mobilization can be carried out in advance. For example, through a framework agreement covering information model updates when required. Once the event occurs, the process proceeds directly to information production. Unplanned events. Here, procurement and contractor selection are a reaction to the event itself. The process follows the familiar route from ISO 19650 Part 2, starting with an invitation to tender. Asset acquisition. Information is received from the previous owner and must be carefully integrated into the asset portfolio. The key activity is verification against the established information requirements. If the information is compliant, the process moves directly to information acceptance. These three paths are illustrated in the ISO 19650 Part 3 process diagram. What differentiates them is the position of the trigger event within the workflow. Information requirements, the starting point of the entire process. Defining information requirements is the critical first step in every process, described in ISO 19650 Part 3. The standard recommends starting with organizational information requirements, derived from asset management policy and overall business strategy. From the organizational requirements, asset information requirements are developed. AIR define the information needed for assets that are critical to the organization, described from the perspective of specific stakeholders. This may include information on component life cycles, criticality to operational continuity, required operational data, and the format and frequency of delivery. From these foundations, exchange information requirements are defined for specific appointments or services. All levels of requirements are interconnected, forming a logical chain from organizational objectives down to operational tasks. Being in line with ISO 7817, defining the level of information need becomes part of this process, helping to align the scope and level of detail with the actual purpose and to avoid information obesity. The accumulation of data that has no practical use. Well-defined asset information requirements and exchange information requirements help suppliers prepare BEAM execution plans, maintain data quality principles, and clearly assign responsibility for maintaining information. Proportionality is essential. Only the information required to support decision-making should be delivered, and in a format that is meaningful to the recipient. Contractor roles and responsibilities across process paths. During the operational phase, the way the delivery team is prepared depends on whether the trigger event is planned, unplanned, or related to asset acquisition. Planned events may require the development of a detailed BEP and contractor selection before any work begins. Unplanned events rely on predefined response procedures, typically activated through framework agreements. In asset acquisition scenarios, the critical activity is assessing the quality of information received from the previous owner and integrating it into the asset information model. In all scenarios, the lead appointed party is responsible for ensuring that delivered information complies with the EIR and is updated within the common data environment. CDE, the Environment for Data Flow and Control, Clause 5.1.11 of ISO 19650. Part 3 states, the asset information model can be held across any combination of new and existing enterprise systems provided that these are appropriately linked and the contents of the AIM are controlled using the common data environment, CDE, workflow, described in ISO 19650, Part 1. A well-designed CDE enables smooth information exchange between parties while maintaining audit trails, version control, and appropriate security levels. In practice, the CDE often supports data quality verification by integrating acceptance processes described in ISO 19650 Part 4. That part of the standard clarifies how to control data reliability and completeness at each information exchange, covering purpose definition, schema and format preparation, validation, and quality control. Only after formal exchange, acceptance and aggregation into the asset information model does information become a trusted organizational asset. I will address this topic in more detail in a separate article. The operational phase also introduces the risk of exposing sensitive information about the asset. This is where ISO 19650 Part 5 becomes relevant, addressing sensitivity assessment, security strategy, and security management planning. When implementing BIM, security roles and procedures should be reflected both in contracts and within the CDE. 2 mini case studies of trigger events. Planned event. Lighting system upgrade. Replacement of conventional luminaires with an intelligent LED system, controlled by presence and daylight sensors. The appointing party issues AIR and EIR, defining the information required to update the AIM, including necessary integrations with enterprise systems, for example, electrical parameters, or BMS integration. The supplier prepares a BIM execution plan proposing data structures and export formats, such as IFC or COBie. During delivery, the CDE, for example a middleware solution linking BIM data with the FM system, is used to collect installation models, connection diagrams, luminaire schedules, and operational parameters. Following verification, the information is accepted and the asset information model is updated with new assets, locations, service identifiers, and relevant parameters. Unplanned event. Air handling unit failure. An air handling unit failure requires immediate response, while a framework agreement is activated in parallel. The EIR specifies the required service data, photographs, and warranty status. After repair, a data package is delivered to the asset information model, including root cause analysis, replaced components, updated parameters, and current instructions. Summary. ISO 19650 Part 3 does not reinvent the wheel. Instead, it provides a structured process in which BIM becomes an everyday tool for asset operators. From clearly defined key assets and trigger events to a continuously developed AIM, the standard supports working with reliable data rather than assumptions, if needs are clearly defined and requirements remain proportional. Postscriptum. A note on the structure of the standard. For over a year now, as of January 2026, ISO 19650, Parts 1, 2 and 3 have been under revision. In addition to editorial corrections and clarifications, conceptual changes are also being considered. One of these concerns the relationship between Parts 2 and 3. The current proposal assumes that Part 2 would remain the primary description of the information management process, from project delivery through to handover, while Part 3 would take on a more supportive, practice-oriented role, guiding the application of these principles during operation. This direction has been formally approved for further development within the revision process, with publication expected in late 2026 or early 2027. Thank you for listening. Wojciech Jędrosz, G for BIM.